For the snow day, I asked you guys to work on some book problems, and I posted the answers up here. I took pictures of them, but I want you guys to watch this video that's me actually working through all of them, just in case you weren't able to get on the answers that I got. So you had to do 1, 3, 15, 18, and 23, and I was starting on page 187. So here's one. They gave me that y is equal to the square root of x. All right, and for the first part, A, they were asking me to find dy dt. And this was when x was equal to 4 and dx dt was equal to 3. So they gave me all of that stuff. All right, well, if I'm going to do that, I obviously need to, anytime I want to find d anything, that means I'm taking the derivative. So I need to take the derivative of the original function. And to do that, the first thing I'm going to do is I'm going to change this radical to an exponent because that's easier. And so when I take the derivative, and I'll do that down here, all right, remember, we take the derivative of both sides with respect to t. All right, and since it's with respect to t, everything in this is going to be junk, because anything that doesn't have a t is junk. So on the left, I'm going to have dy dt. And then on the right, you take the derivative like you normally would. So this would become 1/2 x to the negative 1/2. But the x doesn't have a t in it, so it's junk, so we need to tack on a dx dt. Now, I simplified this, all right? So I changed this to dy dx, and then since that's a negative 1/2 in the exponent, I just changed this to 1/2 times the square root of x dx dt. And now I have everything, and I can plug in this information that they gave me. So I want dy dt, and it's when x is equal to 4. So this is going to become 1/2 times the square root of 4. And dx dt was 3. And this is what dy dx. dy dt, silly me. This is what dy dt is equal to. And then, that's just 1/2 times 2, because the square root of 4 is 2, times 3, so this is just 3/4. And that's your answer, right? We found dy dt. For part B, they wanted us to find dx dt. And they said that this was when, right today, x was equal to 25 and dy dt was equal to 2. So again, we're going to take the derivative of the original function that they gave me, and that is just going to be the same derivative that we did up here. So it's the same work. All right, so I'm going to be working with this derivative because this was once I simplified it. So no need to write all that all over again if you don't want to. All right, so we have dy dt is equal to 1/2 times the square root of x dx dt. And now we can plug in x is 25, dy dt is 2. So x is 25 and dy dt is 2, and I want dx dt. Well, this is going to become 2 equals 1/2 times 5. So that's 2 is equal to 1/10. And to get dx dt by itself, you either divide by 1/10 or multiply both sides by 10. It's the same thing. So either way, you're going to get that 20 is equal to dx dt. And that is that. That's number 1. Number 3 was very similar. They wanted us to find dy dt for part A and dx dt for part B. And our original function was xy is equal to 4. So for part A, that find dy dt when x is equal to 8 and dx dt is equal to 10. So I should probably find the derivative of my original. Okay, I'm going to have to use the product rule in here. So let's take the derivative of both sides with respect to t. When we do the left, I've got the first times the derivative of the second plus the second times the derivative of the first. And then the derivative of 4 is just 0 no matter what. And, you know, you can get dy dt by itself. You could do that now, or you can be lazy like I was and just wait. So I'm just going to sub in right off the bat. So x is 8, dx dt is 10. So I've got 8 times dy dt plus, now I'm going to leave a space here, and they gave me that dx dt is 10, and this is 0. Here's the problem. They didn't give me anything for y. So right now, I don't know what to plug in for y. Well, I don't know, but I kind of know. I can easily find out. Okay, because if x is equal to 8, can't I just plug that in here and it'll tell me what y is? Right, because when x is equal to 8, that's going to give me some y value that I can definitely plug in. So that's what I'm going to do. All right, so to find y, we've got our original, and I know that x is equal to 8 for part A. So that's just 8y is equal to 4, or y is equal to 1/2. So that's what I'm going to plug in here. So sometimes you got to do a little legwork to figure it out. So here we got 8 dy dt plus 5. Subtract the 5 over. And divide by 8. And there is your answer. Okay, exact same thing that we did for 1, except we had to actually do this little piece right here of finding y. So now let's do part B. Let me extend. Okay, and for part B, it wanted us to find dx dt when x is equal to 1 and dy dt is equal to 6. All right, we're using the exact same problem, so it's going to have the exact same equation for the derivative. So I'm still working with x dy dt plus y dx dt equals 0. And now I'm plugging in that x is 1 and dy dt is 6. So I've got 1 and I've got 6. I want dx dt, but I don't have anything for y. Alright, just like before, I didn't have anything. Here I don't have anything, but I'm going to do the same thing to figure it out. Alright, I don't know y, but I know that x is equal to 1. So I got x times y is equal to 4, but x is equal to 1. So we get that y is equal to 4. So that's what I'm going to plug in here. Forgot my equals 0. So I got 6 plus 4 dx dt is equal to 0. Subtract the 6. 4 dx dt is equal to negative 6. Divide both sides by 4. Dx dt is equal to negative 6 over 4, which simplifies to negative 3/2. Hold on, did they tell me that this was negative 6? Well, that's fine. That's just going to change the sign here, and here, and here, and here, and here. Alright, my bad. Yeah, it was negative 6. Tiny error, I fixed it. So that is how you do 3. Exactly how we do 1, except, again, we just had to do this little extra bit of work to find y. And it's very similar to those tangent line problems, right, where they gave us one thing, they gave us part of the point, and then we had to go back and plug into the original to find the other part. This is the exact same thing. All right, they give you the x, you got to go back into the original to find y. The next thing I wanted you to do was 15. And for 15, they give us that the radius of a circle is increasing at a rate of 3 centimeters per minute. Now, I did AK for already know, and I did WD for want to determine. Kind of looks like awkward, so that's how I remember it. But if you just want to do K and W, that's fine. So I know that the radius is increasing at a rate. Okay, so if it's the rate that the radius is changing, that's going to be dr dt. And that's 3. And we want to find the rate of change of the area. All right, so how the area is changing, that's going to be dA dt, and I'm putting it in the wrong column. So we want to know how the area is changing. And then for part A, it says that when the radius is equal to 6. So that's part A. Well, I'm working with a circle, and I want to know something about the area. Area of a circle equals pi r squared. Let's take the derivative of both sides, because I want to find a derivative. When I do that, I get dA dt on the left. Pi is a constant, so that stays. And then the derivative of r squared is going to be 2r dr dt. And you can leave it like that, but most people move the 2 and the pi. So it's 2 pi r dr dt. And now I can just plug in what I know. I know that dr dt is 3, and I know that for part A, r is equal to 6. So I want dA dt. 2 is just 2, pi is just pi, r is 6, dr dt is 3. And if we do 2 times 6 times 3, that is going to give us 36 pi. And remember, area of the units are squared, so this would be centimeters squared per minute. And then part B is pretty much the same thing. I'm still going to do area, all right? But instead, for part B, they have that r is equal to 24. But I still want dA dt, and this is still my dr dt. So, and I'm still using dA dt is equal to 2 pi r dr dt. Except now I'm just plugging in 24 instead of 6. So this is 2 times pi times 24 times 3, which is equal to 144 pi centimeters squared per minute. Okay, so I wrote what I knew, I wrote what I wanted, I did my implicit differentiation, and then I just plugged stuff in. On to 18. 18 has to do with volume. It even says it right there. Now it says the radius of a sphere is increasing at a rate of 2 inches per minute. So I know, and it's how the radius is changing. So that's going to be dr dt, because derivatives are rates of change. And it says that that's 2. For part A, it says we want to know, find the rate of change of the volume. So I want to know how the volume is changing. That's dV dt. When r equals 6, and then they want us to do it again when r is equal to 24. So very similar to the one above. We've got kind of 2 different cases. So I'll do the 6 case in black and the r case in orange. So let's see, I'm talking about volume. Volume of a sphere, that formula is V equals 4/3 pi r cubed. Because we all memorize that one, right? take the derivative of both sides. Here I'm going to get dv dt. Now 4/3 and pi are constants, so those come down. And then the derivative of r cubed is 3r squared dr dt. And what's nice is that this 3 and this 3 will cancel. Always look to simplify, it's going to make your life easier. And so then we're left with 4 pi r squared dr dt. And now I'm just going to plug in what I know. So I want, I said I was going to do this in black, sorry. So I want dv dt, 4 is 4, pi is pi. For the first case, r was 6, so this is 6 squared, and dr dt was 2. So 4 times 6 times 6 times 2, that is going to give me 288 pi. And this is volume, so it's inches cubed per minute. And then the other case was when r was 24. So I'm still going to plug into this, except r is 24. So dv dt is equal to 4 pi times 24 squared times 2. And that is going to give me 4,608 pi inches cubed per minute. All right, cubed because it's volume. And that's that, all right? Just like the previous problem, except instead of radius, we were doing volume, and it asked for 2 different cases. Okay, make sure you're doing, I didn't need a picture for this one, but at least put down a column of what you know and what you don't know. It really helps. And now let's look at, what did I do? There we go. Problem 23, that was the very bottom. All right, and remember I said some of these are more wordy problems. It says, at a sand and gravel plant, sand is falling off of a conveyor onto a conical pile. All right, so if we think about it, the gravel's like going and going and going, and then it's falling. So this conical pile is going to look like this. Okay, if you drew it this way, that's just kind of silly, because that means that there's like 1 grain of sand down here, and then everything's balancing on top of that, which I don't think that's how this works. Anyways, and it's falling onto a conical pile at a rate of 10 cubic feet per minute. Now looking at this, it's clearly something that has volume, so we're probably going to do volume, and it says it right next to 23. But also, if it says 10 cubic, remember cubic is the unit when we're talking about volume. Volume's 3-dimensional, so it's to the 3rd power. So that means that we kind of already know that dv dt is going to be 10. Okay, the diameter of the base of the cone is approximately 3 times the altitude. So the diameter is 3 times, instead of A for altitude, I'm going to put H for height, because if we kind of vaguely remember the volume of a cone formula, it uses height. So an altitude and height mean the same thing, so just kind of make it nicer for you. And it says, at what rate is the height of the pile? So if I want to know the rate of the height, that's going to be dh dt. At what rate is the height of the pile changing when the pile is 15 feet high? So when h is equal to 15. And hopefully we all remember that the volume of a cone formula is volume equals 1/3 pi r cubed h. All right, it's got a cube because it's volume. It's got a pi because there's a circle in it. I don't know. And then cones and pyramids have this 1/3. Now, if we look, we kind of got a problem, because as the volume formula stands right now, we have r's and h's. But if I look over here in my already know column, I only know things about H. I don't know anything about R. So I kind of need to pump my brakes before I take the derivative because I'm going to have a problem. I'm not going to have anything to plug in for R, and I'm not going to have anything to plug in for dr dt. However, if I come over here to Happy Math Land, remember d was diameter. And if the diameter was equal to 3 times the height, well, the diameter is really 2 times the radius. So now I do have an R, and which is good because my volume formula includes R, so that I know that R is going to equal to 3h over 2, which is awesome because now if I plug this in here, I'm getting rid of my R, so I'm getting rid of my problem. So watch. So I get 1/3 pi, and instead of R, I'm going to write 3h over 2 cubed times h. I'm going to clean this up a little bit, because that's really going to be 27, 3 cubed is 27, h cubed over 8 times h. So I just cubed everything on the inside. And then if I look, 3 goes into 27 9 times. So that cleaned it up a little bit, not a whole lot, but I mean every little bit helps. So really I have that the volume is equal to 9 pi over 8. All right, I just put all the constants together. And then I've got 9 pi over 8. Oh, there we go. 9 pi over 8, and then I have h cubed times h. That's actually h to the 4th. Okay, awesome, because now I got rid of those r's that I knew absolutely nothing about. Okay, that was an awkward pause. Let's see. We got everything. Oh, we got rid of the r's. We plugged in everything with h's. So now we can finally take the derivative of both sides, which is a different color. So now we have dv dt, and 9 pi over 8 is just 9 pi over 8. Carry it down because it's constant, and then this is going to be 4 times h cubed dh dt. And now we can plug in what we know, which is hidden up there. Okay. So that's 10 is equal to 9 pi over 8 times 4 times 15 cubed, and I want dh dt. And that's going to be 10. Why am I bending down? 3,375. Wouldn't I be a huge jerk if I gave this to you without a calculator? So I'm going to multiply both sides by a... Oh, you know what? This is what we're going to do. Before I even multiply, let's cancel that. So then we get 10 is equal to 9 pi over 2, and then 15 cubed is 3,375. There we go. dh dt. I'm going to multiply by 2 and divide by 9 pi, so that's going to give me 20 over 9 pi. And then we divide both sides by 3,375, and you can actually do that, or you can be lazy, like me, and leave it like this. And that's it.